determine Thevenin's equivalent corresponding to AB terminal, that is A and that is B. Okay, so how can we start? First of all, I know that what about Thevenin's theorem? Thevenin's, our motto, Thevenin's equivalent corresponding to AB terminal. Okay, so how can make it? First of all, this one is a RL load. Okay, that is corresponding to this one. Okay, this is also A, this is B, also B. So that is load resistance, that is load. Okay, so first of all, make load resistance are removed, and after that determine RTH and VTH corresponding to AB terminal. Okay, so how can we do it? So first of all, we have focus on VTH. We have focus on VTH. That is plus minus 12 volt, and that is 4 milliampere, and that is 2 kilo ohm, and this one is 4 kilo ohm, and this one is 2 kilo ohm. Okay, now that is A and that is B, and this one is removed. First of all, remove. Okay, so circuit look like this one, and that is plus, that is minus, that is VTH. Okay, so our motto, we are focused on how can we determine VTH. Okay, now if follow this loop, this unknown voltage. Okay, that is unknown voltage. So you can follow this path or this path, or if you follow this path, then determine, first of all, determine VTH. Determine this voltage corresponding to current source. Okay, so how can do it? I know that is 4 milliampere. It means in this branch also 4 milliampere, and that is also 4 milliampere. Clear or not? Okay, now suppose that here I1 current, loop current I1, apply KVL in this loop. Current direction plus 2 minus, plus 2 minus. But if you follow and here that is I2. I2 very clear. I2 is 4 milliampere. Why? Because of loop current and branch current are same, and that branch, so for this equal to I2. But what about this branch current? First of all, make the branch, that is 2 kilo ohm. I1 here, I2 here. Okay, what about I1 direction? What about I2 direction? Like this one. Our motto, plus 2 minus, net current in this direction, I1 minus I2, that is I1 minus I2. Clear or not? I1 is stronger than I2. If you consider I1 is stronger than I2, then always take I1 dominate I2, means always prefer I1 direction. So I1, and what about I2 direction? Is opposite to the I1. That's why net current in this branch, that is I1 minus I2. Clear or not? Now, so here I1 and here I1 minus I2. So apply KVL in this loop. Minus to plus, minus 12 plus 4I1 plus 2I1 minus I2, this will be equal to 0. So 6I1 minus 2I2, I2 is 4, this will be equal to 12. So 6I1, this will be equal to 12 plus 8, that is 20. So I1 is 20 by 6, or you can say that is 10 by 3. I1 is 10 by 3. Clear or not? Clear? Now this is also written as 3.33 milliampere. Now next target is follow this path, minus VTH plus 4 I1 is, and plus 2 I2, this will be equal to 0. So VTH is 4 into I1, 4 into 3.33 plus 2 into I2 is 4. So finally 13.332 plus 8, this will be equal to 21.32 volt. That is VTH. Clear? So VTH is 21.32, or better to write here 21.32 volt. Clear? 21.32 volt. Clear? Now next target is our motto, determine VTH. If you determine VTH, means I know that what about, our motto, we are focused on RTH. How can you determine RTH? According to Thevenin's theorem, if you determine RTH, it means you can remove all independent source reduced to be zero. If voltage source or independent voltage source are available, then it is behave as a short circuit, and independent current source behave as an open circuit. Okay, so this one is short circuit and this one is open circuit. So look like this one and this is A and that is B. That is 4 kilo ohm, that is 2 kilo ohm, and that is 2 kilo ohm. So what about RTH? RTH is 2 into 4, 8. Both are parallel, and combination of these two we got with the help of with series 2 kilo ohm. Okay, so 4 into 2, 8 by 6 means 4 by 3 plus 2, that is 10 by 3 kilo ohm. Clear? VTH 21.32 and RTH is 10 by 3. Okay, now after that you make equivalent, Thevenin's equivalent up, and then determine this voltage. Okay, so how can we, first of all, Thevenin's equivalent like this one, RTH, here VTH, and here RL is, here RL, and our motto determine V0. So if you determine V0, means apply voltage divider rule. I know that what about voltage divider? VTH RL into VTH divided by RTH plus RL. Now put this value, and that is 10.3, that is 3.33 also. So RTH is 3.33 and VTH is 21.32 whole divided by 3.33 plus what about RL, that is 12 kilo ohm. After solving this value, 0.7 volt. So finally V0 is 16 point closer to volt is the final answer. Okay. You know how can you basically do it? Our motto, determine V0 across AB terminal. Okay, so how can we determine with the help of Thevenin's equivalent? Okay, first of all, removing this one, this resistance is behave as a load resistance. That's why first of all make equivalent circuit corresponding to AB terminal. Okay, what about Thevenin's equivalent? First of all determine VTH and after that determine RTH. How can you determine VTH? Load resistance are removing, after that make the circuit and find out the VTH with the help of this one. After that, determine RTH, and after that make Thevenin's equivalent, and RL is put here, and after that we determine voltage divider rule, and V0 got 16.70 volt is the final answer. Make it.